Hi guys, so in this video, I'm going to be going over AMC 10A 2021 fall. So the one that just took place in November. All right. So start. So in this video, I'll be doing 1 through 10. All right. So let's see. Number one, what is the value of 2,112 minus 2021 squared over 169? All right, so this one's pretty straightforward, right? Obviously, number one, it's just some math, some arithmetic. So 2112 minus 2021 is 91, right? So basically we have 91 squared over 169, which is 13 squared, right? Which can be written as 91 over 13 squared. Well, that's a terrible 3. Sorry about that. Right, so 91 over 13 quantity squared, which is 7 squared, which is 49. So the answer is C, 49. All right, so that one's really not too bad at all, right? Yeah, which is what you'd expect from number one, right? Okay, so moving on, number two. Okay, number two says Mankara has a 4x6 index card. If she shortens the length of one side of this card by 1 inch, the card would have area 18 square inches. What would the area of the card be in square inches if instead she shortens the length of the other side by 1 inch? Well, so obviously to get 18, she has to make it, so it's 4x6. To make it 18, it would have to be 3x6. Right? So if she had shortened the other length instead, then it would be 4x5, which would give you an area of 20. Right? So again, another pretty easy one for number two, right? Okay. So number three, sorry, just gonna move this bar out of the way. Okay. So number three, what is the maximum number of balls of clay of radius 2 that completely fit inside a cube of side length 6, assuming the balls can be reshaped but not compressed before they are packed in the cube? So I remember like when I did this one, it threw me off a little bit because I kind of read it too fast and didn't realize that you're able to reshape the spheres, right? So it's not just asking how many like whole spheres can just fit in there, because I think that would be kind of easy. So basically it's just volume divided by volume, right? So if you have a cube of side length 6, so that's volume going to be 6 cubed, right? I'll do VC for volume of cube, right? Which would be 216, right? And then the volume, now we know the volume of a sphere is 4/3 pi r cubed, which in this case would be 4/3 pi 2 cubed. So that's 832 pi over 3, right? So basically we need to do, whoops, not what I wanted to do. Basically we need to do, sorry, I'm going to make this smaller to make more room. We need to do 216 divided by, so 216 divided by 32 pi over 3, right? Which what we can do is try to simplify this, because remember, we can't use a calculator. So what I did is like knowing 216 is 6 times 6 times 6. So that's what, 2 cubed times 3 cubed, right? Over 32 is 2 to the 5, right? Over 3 pi. So if we simplify this, that would give us what? 3 to the 4 over 2 squared pi in the bottom, right? Or 81 over 4 pi, right? Now, 81 over 4 pi, and we want to know how many cubes can we fit. So obviously we need a whole number. We can't let the value be larger than 81 over 4 pi or else it wouldn't fit. So it has to be just underneath. So we're essentially looking for what would be the floor of 81 over 4 pi, right? So the greatest integer less than 81 over 4 pi. I'm going to erase just to give myself a little bit more room. So we're trying to find the floor of 81 over 4 pi. Now we know 4 pi is between 12 and 13, right? Pi is 3.14, so it's definitely larger than 12, and it has to be less than 13 because 0.14 times 4 is not greater than 1. It's less than 1, so right? Like we would need it to be at least 0.25 for it to reach the next integer value. So we're looking at a number that's in between 8 over 13, 81 over 13 and 81 over 12, right? The number we're looking for, right? So we can sort of do a little bit of like trial and error. Well, we know 12 times 5 is 60. Right, and 12 times 5 is 60, and 13 times 5 is 65. So 5 is too small. 6 times 12 is 72. 6 times 13 is 60 and 18, 78. Right, so that would. Well, we're looking for the floor of this value, right? So 81 because 12 times 6 is 72. So that's going to be, so this is a little bit larger than 6, right? But 13 times 6 is 78. So this is also a little bit larger than 6. So therefore t is a little bit larger than 6. But 12 times 7 is 84, which is too big. And 13 times 7 is 91, which is larger than, so that wouldn't work. So then t is just t is in between 6 and 7. So therefore the floor of 81 divided by 4 pi must be 6. So the answer is D, 6, right? That one's a little tricky because you have to kind of really think that through, right? Okay. All right, let's see. Number 4. Mr. Lopez has a choice of 2 routes to go to work. Route A is 6 miles long and an average speed of 30 miles per hour. Route B is 5 miles long with an average speed 40 miles per hour, except for a half-mile stretch in the school zone where his average speed is 20 miles per hour. By how many minutes is Route B quicker than Route A? Well, let's find his time for each. So his time for Route A is 6 miles long. Oh, I'm sorry, I don't have a stylus, so that's why these don't come out great. 6 miles long divided by 30 miles per hour is going to tell us how many hours it takes him to go on Route A, right? Well, that's 1 over 5 hours, right? Which is 12 minutes. So he can cover Route A in 12 minutes, right? Yeah. So he can cover Route A in 12 minutes. Route B, he covers 5 miles in going at 40 miles per hour, right? Oh no, sorry, 4.5, right? Because a half of a mile he does at a different speed. So we'll replace the 5 with 4.5. Or 9/2, right? 4.5 is 9/2, right? So that's going to give us 9/80 hours, right? Plus a half mile stretch at 20 miles per hour, which is 1/40 of an hour, right? Now, if we add those together, that's going to give us 11/80. So root B total, right? If I add 9/80 plus 1/40, which is 2/80, I get 11/80, right? Hours, 11/80 of an hour, right? Which if I multiply by 60 gives me 66/8, or 33/4, or 8.25 minutes for root B, right? Remember, root A was 12 minutes. We want to know how much quicker is root B than root A, so we want to do 12 minus 8.25, which gives us 3 3/4, 3.75, 3 3/4 minutes, right? So choice B, 3 3/4 minutes faster. All right. So that one again is just a lot of algebra, but really nothing too hard. Oops, this thing is always in the way. Number 5, the 6-digit number 20210A is prime for only one digit A. What is A? Okay, so this one was really trial and error, using different rules of divisibility. Right away, we can get rid of C, because any number that ends in a 5 except for 5 cannot be prime, is composite, right? Let's think of some other divisibility rules that we know of. One of which would be like the rule for divisibility by 3. So the rule of divisibility by 3 is if you sum the digits has to be a multiple of 3. So if we do 2 plus 0 plus 2 plus 1, whoops, sorry. Let me do that better. 2 plus 0 plus 2 plus 1 plus 0 plus A. So what would make this be a multiple of 3? Well, 2 plus 2 plus 1 is 5. So 5 is 1 less than a multiple of 3. So if A is any multiple of 3 plus 2, or in other words, if A is 2 mod 3, for anyone familiar with modular arithmetic, which, to be honest with you, for AMC 10, it's very helpful to know some modular arithmetic. And I'll be using it in some other problems as well. In fact, I think, not the next problem, but a problem coming up, I will also be using modular arithmetic. So if A is 2 mod 3, then it will not be prime, because you're going to get a multiple of 3, right? Because 5 is 1. Oh, no, I'm sorry. If A is 1 mod 3 is what I meant, because 5 is 2 mod 3. So if A is 1 mod 3, then the number will be a multiple of 3 and therefore not prime. So that would be, for example, 7, right? And also 1. Right? Because if A is 1, it's good. You have 2 plus 2 plus 1 plus 1, that's 6, which is a multiple of 3. If A is 7, 2 plus 2 plus 1 plus 7, that's 8 plus 4, 12, which would make it a multiple of 3. What about to be a multiple of 9? To be a multiple of 9, the sum of the digits has to be a multiple of 9. 2 plus 2 plus 1 is 5, so A would have to be 4 for it to be a multiple of 9. And 4 is not an answer choice. So we're going to have to look at something else. There's one other divisibility rule that can really be helpful in this case, which a lot of people don't necessarily know of. And that's the rule for divisibility by 11. So yeah, a lot of people are not familiar with that rule. Definitely not something that's taught very often in school. I think I learned it when I took number theory. So the rule of divisibility by 11 is that what we say is the alternating sum has to be a multiple of 11. So an example would be I'm sorry, I'm kind of thinking. So 121 we know is a multiple of 11. If we do 1 minus 2 plus 1, so we, instead of summing the digits, you go minus plus minus plus minus plus, starting from the left. 1 minus 2 is -1 plus 1 is 0. 0 is technically a multiple of 11, right? What about 1, 3, 3, 1, right? That's a multiple of 11. 121. Minus, yeah, same thing, right? 1 minus 3 is -2, plus 3 is 1, minus 1 is 0. But it could also be like the sum is 11, or the sum is 22, or the sum is 33, right? So if that's the case, then the number will be divisible by 11. So let's look at the number we have here. 2 minus 0 plus 2 minus 1 plus 0 minus a, right? That's 2, 4, 3, 3 minus a, right? Well, that means that if a is 3, that will equal 0, which is divisible by 11, which would therefore make the number divisible by 11. So therefore, a cannot be 3, so the only choice left is 9, E9. So yeah, that one's tricky because you have to know that divisibility by 11, which is definitely not an easy easy process, you know. So yeah, that one is definitely a little bit it's a little bit tricky, but overall, again, not super crazy. Number 6, I had really hard time understanding what this problem was saying. I think I ultimately did not fully understand the problem itself. But I think it's a lot easier than what I was thinking. So it says Elmer the emu takes 44 equal strides to walk between consecutive telephone poles on a rural road. Oscar the ostrich can cover the same distance in 12 equal leaps. The telephone poles are evenly spaced, and the 41st pole along this road is exactly 1 mile from the first pole. How much longer in feet is Oscar's leap than Elmer's stride? Okay, so if we know that 41 poles at the 41st pole makes up 1 mile, or 5,280 feet. Well, if you think about it, 41 poles means that there's 40 spaces between those poles, right? If you have like, so for example, like if you have 3 poles, right, that's 2 spaces. If you have 4 poles, that's 3 spaces. So if you have 41 poles, that's 40 spaces. So that means the space between each pole is 5,280 feet divided by 40, right? Cancel the zeros. 52 divided by 4 is 13, so 132, right? Right, because 52, 4 times 13, 40, and 12, yeah. So every pole is 132 feet apart, right? Now, Elmer the emu takes 44 equal strides to walk between consecutive telephone poles. So that means 44 of his leaps would equal 132 feet, right? Or 44 of his strides, I should say, right? 44 of his strides equal the 132 feet, right? And then at the same time, 12 equal leaps would also equal 132 feet, right? And we want to know how much longer in feet is a leap than a stride. So a leap is 132 divided by 12, which is 11 feet, right? 44 times 3, 120 and 12. So stride is 132 divided by 44, which is 3 feet. Through 11 feet minus 3 feet is 8 feet. So, and yeah, it's actually a really easy problem, but when I first did it, I completely misunderstood the question. And like I was doing a whole bunch of stuff about greatest common, least common multiple, and I had all these different variables because I think when it was saying equal strides to walk between consecutive phone poles, I think it meant like between the total number of phone poles. And without knowing the total number, that's what threw me off. But they just meant between two consecutive telephone poles. So yeah, just and it definitely, like when it's number 6, it really shouldn't be super complicated. So I definitely overthought the problem. Number 7, as shown in the figure below, point E lies on the opposite half plane determined by the line CD from point A, so that angle CDE is 110 degrees. Point F lies on AD, so that DE equals DF and ABCD is a square. What is the degree measure of angle AFE? All right, well, what do we know? We know DF equals DE. So that means that this is an isosceles triangle, which means this angle, this angle equals this angle, right? Angle DFE is equal to angle DEF. Okay. So what do we know? That angle is 110 degrees, right? And then this angle here is 90 degrees. That makes so that means that this whole thing has to add up to 270, right? 270 minus 110 is 160, right? So that means, angle FTE is 160 degrees. And since it's isosceles, then that means each of these is 10, right? This is 10 and 10. And they want angle AFE. Well, angle AFE will be 180 minus 10, which is 170. So answer is D, 170 degrees, right? So again, really pretty easy, right? The first 10 are usually like, you usually let your guard down because they're really not that bad. But you'll see once we get to, 11 and up, it gets much harder. So we got that. A 2-digit positive integer is said to be cuddly if it is equal to the sum of its non-zero tens digit and the square of its units digit. How many 2-digit positive integers are cuddly? Okay. So 2-digit positive integer is said to be cuddly if it is equal to the sum of its non-zero tens digit. Okay, so if we're going to have a number, like let's say in the form AB, right, like 21 or 38, something like that, right? Then that number can actually be represented as 10A plus B, right? So, okay, so if I'm going to write the number 21, I can write that as 10 times 2 plus 1. 38, 10 times 3 plus 8. So that's how I'm going to represent the number AB as being 10A plus B, right? So what we're saying is the number itself is equal to the sum of its non-zero tens digit and the square of its units digit. So 10A plus B equals A plus B squared. So what I did from this is I converted it into a quadratic. So I got B squared minus B minus 9A equals 0. Right, and then by using the quadratic formula, let me make this smaller. Whoops, not too small. Okay, so by using the quadratic formula, I was able to say B equals 1 plus or minus square root B squared 1 squared minus 4AC all over 2A, or 1 plus or minus square root 1 plus 36A divided by 2. Now, remember, B has to be an integer from 0 to 9, right? So obviously that means that this needs to be an integer, 1 plus 36A, right? And really what this came down to was a lot of trial and error where I basically listed out multiples of 36 and then added 1 to them and determined which one was a perfect square. So this requires you to know some perfect squares, right? So I listed out like 36, 72, 108, 144, and I added 1 to each of them. So 37, 73, 109, 145, right? And I kept checking, like, is it a perfect square? And I know my perfect squares up to 400, so I'm able to just sort of look and recognize if it is or not. So it turns out, so none of them were up until I got to 36 times 8, which is 288, plus 1 equals 289, right? Which is 17 squared. So the only ones up to and anything beyond that is going to result in, because it's going to be 17. 1 plus 17 over 2 is 9, which is, anything bigger than that would cause b to be greater than 9, which is not possible. B has to be between 0 and 9. So that means that a equaling 8 is the only possible situation, right? So for a to equal 8 is the only possible way that this can work. And what you end up getting is you get 1 plus or minus square root of 289 over 2, which is 1 plus or minus 17 over 2, obviously not in a minus sign. 1 plus 17 is 18. 18 divided by 2 is 9. So therefore, the only cuddly number that we know of would be 89. Two-digit cuddly number would be 89. So the answer is B1. Right, so that did come down to some trial and error in terms of listing out multiples of 36 and then checking which one and adding 1 and seeing if it's a perfect square. Right? Okay, so that one's not too bad. Number 9, when a certain unfair die is rolled, an even number is 3 times as likely to appear as an odd number. The die is rolled twice. What is the probability that some of the numbers rolled is even? Well, first we might want to figure out, well, what is the probability of an even? If the probability of even is 3 times the probability of odd, right? But probability of even plus probability of odd equals 1, right? So then we can say probability of even is equal to 3 times 1 minus probability of even, or probability of even is equal to 3 minus 3 probability of even. I don't know why I'm writing diagonally. 4 probability of even equals 3. Probability of even equals 3 over 4. So we know the probability of rolling an even number must be 3 out of 4, which means the probability of rolling an odd number must be 1 out of 4. Right? So that helps us to know what exactly that probability is. Right? So again, I'm sorry. Oh, whoa. Just trying to get this out of the way. Okay, so now, how can we roll a sum of an even? Well, either they're both odd or they're both even, right? The only way to get a sum of an even is either even or odd, right? We could do like even and even, or odd and odd, right? So even and even, which are independent events, right? So probability of even is 3 out of 4. So the probability of getting another even would be just another 3 out of 4 because these are independent events, right? Or plus, right? Probability of odd, which is 1 out of 4, right? So 1 out of 4 times the probability of getting another odd, which is independent, 1 out of 4. So that's going to give us 9 out of 16 plus 1 out of 16, or 10 out of 16, which reduces to 5 out of 8. Right? So the answer is 5 out of 8, which is choice E. Okay, so again, I think that one was like pretty easy. Definitely like this 1 through 10 are pretty easy problems, but it does get significantly harder after number 10. There are some really tough problems in this paper. All right, number 10, which will be the last one I'll do for this video, and then I'll do another video 11 through 15. A school has 100 students and 5 teachers. In the first period, each student is taking one class, and each teacher is teaching one class. The enrollments in the classes are 50, 20, 25, and 5. Let T be the average value obtained if a teacher is picked at random and the number of students in their class is noted. Let S be the average value obtained if a student is picked at random and the number of students in their class, including the student, is noted. What is T minus S? Okay, so well, T is just the average number of students per class, which is basically just 50 plus 20 plus 20 plus 5 plus 5, whoops, right? Divided by 5, which is 10 plus 4 plus 4 plus 1, whoops, plus 1 plus 1. That is 20, right? So T is 20, right? That's pretty easy. You're just averaging those 5 numbers. To get S is a little bit trickier because you need to think about, like, if you randomly pick a student, how many students are in that class? Well, if you pick any of the 50 students from this class, the number of students in their class is 50. So for any of those 50 students, they would say 50. So you have 50 50s, right? And then for any of the 20 students in this class, they would say 20. So you have 20 20s, and then you have another 20 20s, and then you have 5 5s, and you have 5 5s. And then remember, this is average number of students per class per student. So we need to divide by the number of students, which is 50 plus 20 plus 20 plus 5 plus 5, which is 70, 90, 100, right? So it's dividing by 100. So now we can, this may look complicated, but it's really not that bad. Because if you think about it, like if you look at here, 50 times 50, you can basically just cancel the 2 zeros out because it's like each of those is like a 10, right? So you have 25 plus, cancel these 2 zeros out, 4, plus cancel these 2 zeros out, 4, plus now 25 divided by 100 is 1 out of 4. 25 divided by 100 is 1 out of 4, right? So if we add this up, 25 plus 4 is 29, plus 4 is 33. So we get 33 plus 2/4, which is 1/2, right? So we get 33.5 is S, right? So T is 20 and S is 33.5, right? And they want us to know what's T minus S. So T minus S would be 20 minus 33.5, which would be negative 13.5, which is choice B, right? So the answer to number 10 is B. Okay, so that was 1 through 10, which again are really not that bad. So join me in my next video where I will go over 11 through 15. All right, and please let me know if you have any questions, comments, a better way to do a problem. I'm always interested to hear that. So see you in the next video.